Welcome. So here we go. What I have is sine of theta equals 3 over 5, where theta is in the second quadrant. So we need to remember where the second quadrant is. So I drew a little picture up here, and we say the second quadrant's right here. Now, why is it important to know if it's in the second quadrant or not? Well, it's very important because if you kind of draw our triangle, what we always did was when I said there was a point, not on the unit circle, I said always draw a triangle, right? And usually the more kind of famous triangle we'd always do is they're like, oh, well, if here's like 3, 5, a lot of times we just draw, any sort of triangle, we do the Pythagorean theorem. But if I say 3/5, then I could say my triangle, remember sine represents y over r. So that means my y coordinate is going to be 3. So that it can be 1, 2, 3. So I could have a coordinate with 3 over here, but I could also have a coordinate with 3 over here. So when I go ahead and look, when I talked about creating triangles, remember that was always to find your coordinate point and then create 2 perpendicular lines. Then you create your right angle, and therefore you could say theta's here or theta's here. So our hypothenuse we know is 5, and our opposite, or our y coordinate, is 3. So the reason why it's important is because we have 2 different triangles. And what you notice is in the first quadrant, my x value is going to be positive. But in the second quadrant, my x value is going to be negative. So it's very important for you to be able to follow what the constraint is for the problem. So therefore, what I need to do is I need to determine what my x value is. Now, I know that this is a Pythagorean triple, meaning that I know that 3 squared plus 4 squared equals 5 squared. Therefore, I can use reasoning to go and say that this is going to be 4. However, since it's in the second quadrant, my x value is going to be negative 4. Now that I know all the sides of the triangle, I can evaluate all my 6 trigonometric functions. So the first one I always like to do is sine of theta, which represents from theta is the opposite side over the hypotenuse. Then we can do a cosine of theta, which again is the adjacent side over the hypotenuse. So that's going to be negative 4 over 5. Then we can look at the tangent, which is the opposite over the adjacent. Then let's go ahead and do the reciprocal properties. So the reciprocal property of sine is cosecant of theta, which will be 5 over 3. The secant, which is the reciprocal of cosine, is going to be 5 over negative 4. And then the cotangent, which is the reciprocal of tangent, is going to be negative 4 over 3. So there you go, ladies and gentlemen. That's how you find your 6 trigonometric functions when given a point and a constraint. Thanks.